In this question, you given the functional equation fx plus fy is equal to f of x plus y by 1 minus xy for all x belongs to -1 to 1 and limit x tends to 0. If something goes to 0, f of something by same thing is equal to 2. You're asked to find f of 1 by root 3 and f dash of 1. Again, this is a functional equation. So first, the shortcut method is that whenever you're given this question, so looking at this functional equation, so if you can guess what this function is, so that is one way to solve this question. So f of x plus f of y is f of x plus y by 1 minus xy. So f of x looks related to tan inverse x, right? Because we know that tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. So f of x is related to tan inverse x. This is my guess. But as you can see, as x tends to 0, fx by x, tan inverse x by x is equal to 1. But in the question it's given that it is equal to 2. So my function, should that be exactly tan inverse x, or can it be some k times tan inverse x, where k can be any number? So let us see whether this function satisfies this equation or not. So what is f of x plus f of y? F of x plus f of y is k times tan inverse x plus tan inverse y, fx plus fy. And what is f of x plus y by 1 minus xy? That is k times tan inverse of x plus y by 1 minus xy. As you can see, the right hand side and left hand side are exactly same. So for this functional equation to be valid, f of x can be any k times tan inverse x. Now this k can be decided to follow this equation. So limit x tends to 0, k tan inverse x by x is obviously equal to tan inverse x by x, as x tends to 0 is 1. So this limit is equal to k, hence this is given as equal to 2, hence k equal to 2. So f of x is equal to k tan inverse x. So once you have this, what is f of 1 by root 3? So 2 tan inverse x. So f of 1 by root 3 is 2 tan inverse of 1 by root 3, which is equal to pi by 3, 2 times pi by 6. And what is the differentiation of this? What is f dash of x? F dash of x is 2 by 1 plus x square. 2 by 1 plus x square. And what is f dash of 1? F dash of 1 is equal to 2 by 1 plus 1, 2, which is equal to 1. So f dash of 1 is equal to 1, f of 1 by root 3 is pi by 3. So this is one way in which you can solve objective questions. It is seeing the functional equation, you have to guess what the function might be. This might not always work. Sometimes the functional equation will be difficult such that you cannot guess what f of x is. So in that cases, you have to do the analytical method. And there is no particular process for these type of questions. You need to think depending on the question. So let us try to assess what we can do with this question. So let us do the general method. The first step, I'll put both x and y as equal to 0. So f of 0 plus f of 0. Put x is equal to y is equal to 0. This implies f of 0 plus f of 0, 2 times f of 0 is equal to f of 0 plus 0 by 1 is f of 0. This implies f of 0 is equal to 0. So we got the value of f of x at x is equal to 0. Next, what I'll do is put y is equal to minus x. So once I get f of 0, I'll try to use my f of 0. put y is equal to minus x. This implies fx plus f of minus x is equal to x minus x becomes 0 is equal to f of 0, which is equal to 0. So fx plus f of minus x is equal to 0. Next, third. So let us use the first principle. What is f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. So what I do is, in the place of minus f of x, because fx plus f of minus x is equal to 0, minus f of x will be equal to f of minus x. So this can be written as limit h tends to 0 f of x plus h plus f of minus x by h. So this implies so now f of x plus h plus f of minus x. So f of x plus f of y, f of something plus f of something. So this is something, this is something, is equal to limit h tends to 0 f of this plus this by 1 minus this into this, x plus h plus minus x, that is h by 1 minus of x plus h into minus x, that is 1 plus x into x plus h by h. As we can see, as h tends to 0, h by 1 plus x into x plus h also tends to 0. So what I do is, I'll divide this with 1 plus x into x plus h and multiply it with 1 plus x into x plus h. So as something tends to 0, if h tends to 0, h by this whole thing tends to 0. So as something tends to 0, f of something by same thing, this is given as equal to 2. X can be anything that tends to 0. You should have f of something which tends to 0 by same thing. So here also, as h tends to 0, h by 1 plus x into x plus h, this goes to 0, f of this by same thing. This whole thing goes to 2. So once this goes to 2, if you put h is equal to 0, 1 plus x square. So that is equal to 2 by 1 plus x square. So f dash of x is equal to 2 by 1 plus x square. So f of x is equal to integration of this, it is 2 tan inverse x plus some constant, but f of 0 is equal to 0, we have derived this. So if you put x is equal to 0, f of x has to be equal to 0. This implies 0 is equal to 0 plus c, which implies c equal to 0. So this implies fx is equal to 2 tan inverse x. As you can see, got the exact same function. F of x is equal to 2 tan inverse x. In the first method, you have straightly guessed the function. In the second method, we have derived the function. So once you derive this function, you can do the same things that we have done in the previous method. F of 1 by root 3 is 2 tan inverse 1 by root 3, which is pi by 3. And f dash of 1, f dash of x is 2 by 1 plus x square. So f dash of 1 is 2 by 2, which is equal to 1. So this is how you can solve this question.